The concentration of a solute can be expressed in several ways, typically 4 types. First, molarity, which includes concentration, mass percent of solute. Third one is molality, and fourth one is mole fraction. So in this presentation, we'll study how to calculate concentration of a solute in several ways. Let's talk about molarity. Molarity is moles of solute per liters of solution. So in here, temperature affects molarity. It's moles of solute per liters of solution. Let's talk about molality. It's moles of solute per kilogram of solvent. It's represented as small m, molality. Molarity is represented as a capital M, whereas molality is presented as a small m, moles of solute divided by kilograms of solvent. Now, mole fraction. Mole fraction is the moles of component over the total moles of the solution. It is abbreviated capital X. Moles of solute divided by total moles of solution. And fourth one is mass percent of solute. It is a percentage by mass of solute in a solution. We can write formula mass percent of solute equals grams of solute divided by grams of solution times 100%. Now let's take an example. An experiment calls for 36 grams of a 5% aqueous solution of potassium bromide, KBr. Describe how would you make up a solution. Here percent is given. So first thing we need to consider what we need to calculate. So in here 5% aqueous solution of KBr has 5 grams of KBr per 100 grams of solution. So in 100 grams of solution, there are 5 grams of KBr. So what we have? Water is what? 100 minus 5, which is 95 grams. Now, we know mass of KBr, which is 36 grams in a solution. So when we calculate 36 grams of solution times 5 grams of KBr divided by 100 grams of solution, you can get 1.80 grams of KBr. So we can call 1.80 grams of KBr required for 36 grams of solution. So we can make mixing 1.8 grams of KBr in 34.2 grams of water. So using this percent calculations, we can calculate solute and solvent. Now let's take another example. Iodine dissolves in a variety of organic solvents. For example, in methylene chloride, it forms an orange solution. What is the molality of a solution of 5 grams of iodine in 30 grams of methylene chloride? Now we need to calculate molality. Molality is moles of solvent, moles of solute divided by kilograms of solvent. So let's see, we have mass of solute, which is 5 grams. And mass of solvent, which is 36 grams of methylene chloride. So first we need to convert iodine. 5 grams divided by 30 grams, which is formula weight. It's a 5 grams divided by 253 grams of iodine. That's the formula weight of iodine. And we have 30 grams of CH2Cl2, which is solvent, and we convert into kilogram by multiplying this unit conversion factor. When you convert 30 grams to kilogram and when you convert this 5 grams into moles, you can calculate molarity, which is 0.657 moles per kilogram. Now, let's take an example of mole fraction, a solution of iodine I2 in methylene chloride, which contains 5 grams of iodine and 56 grams of CH2Cl2. What is the mole fraction of each component in this solution? So we know 5 grams of iodine and 56 grams of CH2Cl2. So what is the moles of solute? We have 5 grams divided by formula weight of iodine, which is 253.8. You get 0.0197 mole of iodine. And we need to calculate moles of solvent, which is 56.0 grams of, this is a typo, it should be CH2Cl2, times 1 mole of CH2Cl2, this is the formula weight, 84.93 grams is the formula weight of CH2Cl2. You get 0.6594 mole of CH2Cl2. So total moles you get solute, which is 0.01970 mole, plus 0.6597 mole, you get 0.6791 mole. So we have mole fraction part divided by total for I2, which is 0.0290%, and we have CH2Cl2, which is a 0.971 mole fraction. Now we need to calculate mole fraction of ethyl alcohol, and density is given. Let's wait for next presentation. We'll discuss this example.